Imagine waking up tomorrow and everything feels heavier. Your legs, your chest, even the air. The sky looks wrong, the oceans have moved, and nobody can explain why. Earth didn't change its address in the solar system, it just doubled in size. A super Earth, except this one is still your home. Hey, I'm Tony. On this channel, we dig into space and cosmos stuff in a way that actually makes sense. No jargon, no guesswork, just the fascinating truth about our universe. So, here's the question. What if Earth's size suddenly doubled? Not some distant exoplanet in a telescope, our Earth. The one with your house on it, your morning coffee, your entire life. What actually changes? In this video, you'll discover 5 massive consequences of living on a bigger Earth. And trust me, they go way beyond just feeling a little heavier. We're going to cover what happens to gravity, to the air you breathe, to the oceans, to the ground beneath your feet, and finally, to us, to the human body itself. And honestly, point number 4 is the one that caught me completely off guard. Quick note, this is a thought experiment based on current physics and planetary science, not a prediction or professional consultation. It's here to make you think, not to make you panic. Now, let's double this planet. Point 1, gravity effects, and they're way worse than you think. If Earth were twice as big but made of the same stuff, its mass would go up roughly 8 times. That's not a typo. Volume scales with the cube of the radius. So gravity on the surface could jump to something around twice what we feel right now. That means you, sitting there weighing, let's say, 150 pounds, would suddenly feel like 300. Your knees, your spine, your heart, everything is now working double shifts just to keep you standing. Walking up a flight of stairs would feel like hiking with a full pack on your back. Even lifting your arms would be exhausting after a while. And here's what really gets me. Remember the Hook, a super Earth that's actually our home? This is what that looks like on day 1. Not some alien planet in a documentary. Your Monday morning, but gravity just decided to ruin it. Now, before you think the gravity effects are the worst part, wait until you hear what happens to the air above your head. Point 2. The atmosphere thickens, and not in a good way. With stronger gravity pulling everything down harder, the atmosphere compresses dramatically. More gas gets trapped closer to the surface. Air pressure could roughly double or more at sea level. Think about what that means. Every breath you take pushes harder into your lungs. The sky might look different too. With a denser atmosphere scattering more light, sunsets could stretch across the entire horizon in deep oranges and reds. Sounds beautiful, right? Except the same thick blanket of air would trap significantly more heat. We're talking about a turbocharged greenhouse effect, temperatures climbing, weather patterns going haywire. Storms on this bigger Earth wouldn't just be stronger, they'd be monsters. Hurricanes with denser air to work with could pack far more energy than anything we've ever recorded. Have you ever been somewhere with really heavy, humid air and felt like you just couldn't get a full breath? Now multiply that by a factor you'd rather not think about. That's Tuesday on a doubled Earth. But the atmosphere is only half the story of what's happening on the surface. Let's talk about the water. Point 3. The oceans don't just rise, they rearrange everything. Stronger gravity pulls water more aggressively toward the lowest points on the surface. Mountains that currently sit above sea level could find themselves much closer to the waterline. Coastal cities? Many of them would simply be underwater. And it's not just about the water level. Tides would behave differently. The moon's gravitational pull on a bigger, more massive Earth would still exist, but the way water responds changes when there's that much more gravity holding it down. Tidal ranges might actually shrink, meaning less dramatic high and low tides, but a permanently higher baseline ocean level. River systems would slow down in flatter areas and carve deeper in steep ones. The global water cycle, evaporation, clouds, rain, would shift in ways that are honestly hard to fully predict. Some regions could get dramatically wetter, others could dry out completely. So we've got crushing gravity, an atmosphere that suffocates, and oceans that have redrawn the map. That's 3 out of 5. And I know what you're thinking. It can't get worse, right? Oh, it does. Point 4 is the one that genuinely surprised me. Still here? Good, because what happens underground on a bigger Earth is something most people never even consider. Point 4. the planet's geology goes into overdrive. A bigger Earth means significantly more internal heat, more radioactive material in the core and mantle, more gravitational pressure generating thermal energy. The inside of this planet is now running much hotter, and when the engine underneath your feet gets supercharged, the surface pays the price. Tectonic plates would likely move differently, possibly faster, possibly with more force. Earthquakes wouldn't just be more frequent, they could be dramatically more powerful. Volcanic eruptions could become a regular feature of daily life, not the rare events they are on our current Earth. Think about this. On our regular-sized Earth, a major volcanic eruption can alter global temperatures for years. On a doubled Earth with even more geological energy, supervolcano events might happen on timescales of thousands of years instead of hundreds of thousands. The ground you'd want to build a city on might not stay solid long enough to make it worth it. And here's where I keep coming back to the core idea of this whole video. This isn't some alien world we're touring for fun. This is the Super Earth scenario, where everything familiar becomes dangerous. Your backyard, your city, the mountain you hiked last summer, all of it, destabilized. Alright, so the planet itself is trying to shake us off. Which brings us to the final point, and it's about us. Point 5. What a bigger Earth does to the human body. Let's start with the heart. Under double gravity, your heart has to pump blood against twice the resistance to get it up to your brain. Cardiovascular stress would skyrocket. Heart failure could become one of the most common causes of death, and not just in the elderly. Your bones would start to thicken over generations, assuming we survived long enough for evolution to even kick in. But in the short term, fractures and joint damage would be everywhere. Simply falling down, something a toddler does dozens of times, could become genuinely dangerous. Breathing would be a constant struggle. With higher air pressure and gravity compressing your chest cavity, every inhale requires more muscular effort. Athletes, people with respiratory conditions, anyone at higher altitudes, they'd be the first to suffer. And here's the part that really makes you pause. Pregnancy, childbirth, carrying an infant, all of it becomes exponentially harder under higher gravity. Growing up as a child on this planet would be a completely different physical experience. We often talk about humans colonizing super-Earths out in the galaxy someday, but this thought experiment shows just how unprepared our bodies actually are. So could we adapt? Maybe. Over millions of years, with shorter, stockier frames, denser bones, more powerful hearts. But the species that would eventually thrive on a doubled Earth probably wouldn't look much like us at all. Now, before we wrap up, let me clear up a few things people get wrong about this topic. First myth, twice as big just means twice as much gravity. Not that simple. Gravity depends on both mass and radius. If the planet doubles in radius with the same density, mass goes up by roughly 8 times, but surface gravity doesn't go up 8 times because you're also farther from the center. The math works out to roughly double surface gravity, but the relationship is not one-to-one with size. Second myth, we could just build stronger buildings and adapt. The engineering challenges aren't just about making things tougher. The atmosphere, the geology, the biology, they all change simultaneously. You can't engineer your way out of your lungs not working properly. Third myth, a bigger Earth would have a bigger moon. Not necessarily. The moon's size is a result of its own formation history, not Earth's current size. A doubled Earth might capture the moon into a closer orbit, or the moon's orbit might become unstable. It wouldn't just scale up politely. Those misconceptions aside, let's bring it all together. Alright, let's recap what a doubled Earth actually looks like. We started with gravity, roughly twice as strong, crushing everything from your joints to your morning jog. Then the atmosphere, thickening into a pressure cooker that traps heat and breeds monster storms. Oceans that don't just rise, but completely reshape the planet's geography. The geology going haywire, earthquakes, volcanoes, a surface that can't sit still. And finally, the human body, pushed to its absolute limits just trying to survive a normal day. Remember where we started, a super Earth, but it's our home. That's the part that makes this thought experiment hit different. It's not a sci-fi movie, it's physics applied to your zip code. Quick reminder, Everything in this video is a thought experiment based on known planetary science. It's meant to help you think about how our planet works, not to cause worry. The Earth's size isn't changing anytime soon. The real takeaway? The planet we already have is precisely tuned for us, and even a small change to its size would make everything unrecognizable. If this made you look at the ground a little differently today, drop a comment. Which of the 5 consequences surprised you the most? Hit subscribe if you want more space deep dives like this, and I'll see you in the next one.